Okay, this is AP Stats, Chapter 8, Day 2, and we're going to be doing, this is a little tedious, which is why I'm recording it. It makes it a little bit easier. So make sure you have your calculator out, and I got to get mine out real quick here by turning this thing on. It'll come up in a second here, and we are doing confidence intervals for a proportion. Remember, you got two kinds of stats. Almost 95% of all stats are two kinds: means and proportions, averages and percentages. Very common. Okay, that's almost every single time. That's what it is. And I'll show you some of the calculator shortcuts as well. So as always, I say the same thing. Make sure if you to stop the video, to write things down, no problem at all. All right, so the first thing we need to establish is whenever you do a study of any kind, the big picture is we're doing a study to try to figure out what the approximate percentages of something. So for example, what percentage of people would vote for candidate A in an election? We ask some people, and based on that response, we have an interval where we think the truth lies, where we think it lies, okay? If you want to know what percentage of students at La Quinta like the roast beef sandwich that they sell on Thursdays, we could ask 50 people. If we do the study correct, we would get a percentage, but we wouldn't get the exact percentage in all likelihood. We would develop an interval of where that percentage lies, okay? So there are 4 requirements for a legitimate study, 4 of them. And they make an acronym that I have labeled as SPIN. This is not something that's, textbook. It's not technical. It's just something that I developed, me and a bunch of other stat teachers. S stands for representative sample. Often it's through an SRS, but it could be another type of sampling procedure. But S means you got a good sample, a representative sample. Okay. P stands for the population is at least 10 times the sample size, also known as, AKA, please write this down, also known as the 10% rule. And the rule is do not sample more than 10% of the population. The reason is you'll violate some laws of replacement. Okay, now what's strange is you would think that sampling more is always better, but it's actually not always the case. It is a strange requirement. It doesn't pass the common sense test. It's a little more technical. I is everybody's independent. And N is the big one. How do you know if you have enough samples for a normal curve? You have to put it to the test on 2 things. N times P has got to be greater than 10. So the number of samples times the estimated percentage has to be bigger than 10. And then N times Q. And by the way, Q is 1 minus P in a lot of books. N times Q is also bigger than 10. Okay, those are things you got to test. And these are the conditions that we will write out in the context of the problem before we do the calculations. We'll say we got a legit study because of the following, okay? You just can't sample 5 people and say, here's my conclusion. No, there are rules to sampling. You gotta get a good sample. You can't sample too much. All the samples gotta be independent. And then you gotta have a large enough sample for a normal curve. Makes sense if you really think about it. Okay, now I'm gonna walk you back through some review stuff as well. So a normal curve. Remember, on a normal curve, 68% of the time you'll get between 1 standard deviation of the mean. So if you wanted to do a 68% confidence interval, it would be 1 standard deviation from your estimate. That makes sense. Okay, let me change colors. If you wanted to do a 95% confidence interval, that's 2 standard deviations from the mean. Technically, it's 1.96 standard deviations, just so you know. 2 is a rounded number. If you wanted to do a 99.7% confidence interval, this is in purple, then you would need to be within 3 standard deviations of the mean. So your estimate plus or minus 3 standard deviations makes perfect sense. The 95% confidence interval is the bellwether one. It's the one almost always used. If you ever see anything on TV or in a magazine or some literature, they almost always do a 95% confidence interval. So that's 1.96 or around 2 standard deviations from your estimate plus or minus. Okay? All right. Now, first thing we're going to do here is we're just going to practice. I'm going to make this a little smaller here. We're just going to practice writing out the requirements. And we're going to do a little work with the standard deviation just to give you a heads up on this. All right. So McNapoly, it's a made-up place, restaurant offers prize tickets in their Jolly Meals, claiming that 35% of those tickets are winners. All right. Do you have a legit study? Sometimes we're going to use the word assume. We use that a lot because oftentimes you really don't know if you have a legit study. So you assume you do for the purposes of academia. Now, if you were actually doing it, you'd have to prove that it was a representative sample, okay? So I do bullet points, S-P-I-N, right? Spin, acronym. You don't have to write out S-P-I-N, you just gotta do the work. So S, here's a good sentence frame. We have a representative sample of prize tickets. Great. Your next sentence, this is the 10% rule. The population time is at least 10 times 300 tickets or 3,000 tickets. I am sure that we have more than 300 Jolly Meal tickets out there, okay? Each prize ticket's independent. Now you got to see if you have enough samples, okay? Here's N, 30. Here's P, 0.35. That's bigger than 10. It's 10.5. And then here's N, 30. Here's P, 0.65. That is 19.5. We have enough samples for we have enough for a normal curve. We're good. So we have met the 4 criteria to do this. Now, before we actually develop the actual confidence interval, we're going to go ahead and just going to practice a little bit, okay? So here we go. So I just want you to make the standard deviation real quick. The standard deviation is P, 1 minus P over N. We know that from the last chapter in chapter 7 as well. It's about 9%, 8 or 9%. So I'm just going to label the normal curve just to do it, okay? So 0.35 goes in the middle, right? 0.0887 is 3 standard deviations away. 0.1758 is 2 standard deviations away. And 0.2629 is 1 standard deviation away. Now, these ones go the other way. So this one is over here. This is the first standard deviation. Circle this one. This one is the second. And this one is the third. Okay, just to kind of give you a sense of that. Okay, so go ahead and take the time to write that down. You won't have to bundle this up. You can get that written out all the way across. So that'll take you some time. Might want to pause the video. All right, the next one. The next one is a poll conducted on 538 voters found that 317 of them prefer the Republican candidate. So that's P hat. And by the way, I spelled out P hat because I can't find the hat on the typing, but it's P hat is 0.589. I just got that by dividing 317 over 538. No problem. Okay, do we have a legit study here? Let's go through it. The S, right, in spin. We have a representative sample of voters. We're assuming that. And by the way, I usually write the word assume that, colon, and then do my 4 bullet points, okay? The population size is at least 10 times 538, which it is, okay? There's at least 5,380 voters for sure in any election. Each voter preference is independent. Assume that. Now, we don't got to assume this, but there is your sample size check. N times P is definitely greater than 10, comes out 316 or 317. And then N times 1 minus P comes out 221. Okay, so we're way bigger than 10. We're good. We have a legitimate study. Now, just to work on the empirical rule so you get a sense of it, this is P hat, the one that's bolded there, 0.589 right here. That's bolded. That's P hat. And that's the one that's 317 divided by 538. Okay. Now, the standard deviation of this is going to be really small, about 2%. P, 1 minus P over N square root. So I got to subtract about 2% each time. So here's this is your standard deviation of your z-score of -3. Here's -2, and here's -1. There's the numbers right there. Okay. Then on the other end, these three go right here, here, and here in that order. Okay. So there you go. And to take a quick look at this, remember 95% confidence is about 2 standard deviations away from the mean. So if you take those two numbers, the z-score of -2, which is 0.5466, and then you take the one that's positive 2 standard deviations away, 0.6314, you would say that based on this study, I'm 95% confident that the percentage of people that were pro the Republican candidate is somewhere between 54.66% and 63.14%. I got 0.589, but if I did a new sample, I'd get a new answer for sure. But I'm pretty confident based on that sample. In fact, I'm 95% confident if my study's done correctly, and I'm assuming it is, that it's somewhere between here and here is the truth. That's what a confidence interval is all about. You know you don't have the exact answer, but you're 95% sure it's within a bracket. That's the idea. Okay? All right, next one. Okay, the next one is 37 adult women were asked if they agree with the statement being a stay-home mom is a job. Of course it is. 29 of these women agreed with that statement. So P hat, and you know P hat is this symbol right here. P hat is the sample, 0.784. No problem. Assuming we have a representative sample of adult women, fine. That's the S in spin. Assuming the population is at least 10 times greater, yeah, 370 women. It's at least 370 women. Each opinion's independent. Now, check this out. The sample size is actually too small on one of them. It's N times 1 minus P is actually too small. It comes out about an 8. So you would need to get more samples. You would not want to do any conclusions based on this data, just so you know. I went ahead and did it because I wanted you to practice it, but realize we did not meet minimum sample size requirements. Okay? All right. Next part is I'm going to do the standard deviation, which is P, 1 minus P over N. It comes out a little less than 7%, 0.0677. Okay? And that's a really big standard deviation. It's really large because the sample size is so small. Recall, the larger the sample size, the smaller the standard deviation. And the reverse is true. The smaller the sample size, the larger the standard deviation. I think it's amazing. We talk about small samples vary more than larger ones. Well, here it is. This is a small sample and it varies more. The math even helps you understand that. So check this one out. I'll let you guys draw those numbers yourself, but check this out. The standard deviation for -2, 0.6486, and then the standard deviation, or the number for +2 is 0.99194. So I'm 95% confident that between 64.86% and 91.94%, of women say that being a single mom is a job. That is a huge margin, huge. It's because the sample size is so small. Typically, Google, I'm going to try Google, companies that do surveys, I guess Google does surveys too. They usually want about 1,500 results because that'll give you a margin of error about 3%. Okay. Now, all we've been doing is practicing getting to know the requirements. We are not yet actually calculating one of these things yet, one of these confidence intervals. We haven't done it yet. Now, the next thing we're going to do is calculating sample size requirements. Often people ask, well, how many samples do you need? Well, it's how many samples you need is what do you want for your margin of error? Okay. So remember, here's your margin of error. Okay. The margin. So here's the whole formula. It's p hat plus or minus z star. And what z star is, it's the inverse of the z-score table. If you want a 95% confidence interval, then it's about 2 standard deviations from the mean. It's actually 1.96, okay, times p, 1 minus p, which I'll call q, over n, okay? And it's probably going to be p hat in here because you're going to use the estimate, okay? Here's how we're going to do that, okay? This is going to be pretty cool. Okay, so let's go over 2A here, okay? So if the sample comes in at 68% of some situation, and you want to be 95% confident, and you want to be within 5%, you want the margin of error to be 5%, then the question is, how many samples? You can see the work done there for you. Okay, let's go through this, okay? So what you got here is you have a confidence interval is made by going your sample, p hat, okay, plus or minus. So this would be 68% plus or minus. Then we're going to do z star, okay? And I'm going to do z star in a second here. And then we're going to, in fact, I'll do it right now, okay? What is z star? If I want to be 95% confident, so what you do is you go over to your year-long formula sheet here, okay? And you find this page, and this is in the back of any book, and then you say, all right, 95% confident. You see that? Look at the number right above it. It's under the infinity symbol, and we're going to use that one for proportions. We're going to use this one for proportions. We're going to use a different one for means, but we'll talk about that later for proportions, okay? Look right above it. We know that 95% is about 2 standard deviations. It's technically 1.96. Remember, if you wanted 99.7%, it's about 3 standard deviations. Look at 99.8, it's about 3. Look at 68%. There isn't 68, but there's 70. 70 is about 1 standard deviation. Remember the 68, 95, 99.7 rule? You see it played out here. So most people remember 95% as 1.96. They just remember it. Makes it easy. Okay. So let me slide back over here. So Z star, and that's going to be 1.96. 1.96 times, we're going to use p hat, 1 minus p hat over n. And n is what we're trying to solve. Now, I just need this part right here. Okay, this will be 0.68, 0.32 over n. I just need this part, and I'm going to set it equal to I'm going to set it equal to 0.05. Okay, so let's look at it. Okay, now that you're looking at this, let me draw this out a little bit better for you. Okay, so 5% right here is 0.05. Okay, equals Z star 1.96 times P 0.68, okay, times 0.32 over n. And you got to solve that for 0.05. Now, this is where you got to use your algebra, okay? And you should know how to do that, okay? But this is your answer, 334.37. You're going to see approximately 335 samples to get it within 5%. Okay. All right. Let's do the next one now. Let's do part B, or question B. P is 68%, 95% confident. We want to be within 2%. All right. So write this one down. Okay. I did O2, 2% equals. Okay. Remember, it's Z star times P hat 1 minus P hat over N, okay? So 95% is 1.96, okay? And then it's gonna be 0.68, 0.32 over N. And you're gonna solve that. So when you solve that, you're gonna take 0.0. In fact, let me do this one for you just in case you get stuck here, okay? So I'm gonna take 0.02 and I'm going to divide it by 1.96. Hit enter. Okay. Now I'm going to square it. See if you can. I'm going to square it. Okay. I'm going to get a crazy answer. And then I'm going to take 0.68 times 0.32, and I'm going to divide that by second answer. Again, I got about 2090 somewhere in there. Okay, that's not hard to do, but maybe when you first see it, it can be a little bit tricky. Okay, and there's your answer right there. Okay, let's do another one. Okay, 2C here. Okay, 18 of the 52 people polled said they believe in ghosts. At a confidence level of 90%, we want our margin of error within 3%. No problem. Okay. First thing, I need to get how many standard deviations away is 90%. So I'm going to go to my formula sheet. Okay. I'm going to go to my formula sheet. 90%, as you can see right here, is 1.645. Most people memorize these two. 90 is 1.645 and 95 is 1.96. All right, so 1.645. All right, no problem. So let me go back to this. Okay, so I'm going to write it out even though it's written there again. So I'm going to go 1.645 times 18 out of 52 is about 35%. It's about 35, then 65 over N, and that equals 3%, 0.03. So this is a little bit better done. And you'll solve it, you get about 681. Okay, about 681. Okay. The next one, D, I'll do all the way through, including the calculator. Okay. All right. 42 of 97 people surveyed said they will not vote in the upcoming election. At a confidence level of 99, we want our margin of error within 4%. All right. First thing, I need to get 99% confident what that is. 99% confident is 2.576. Okay. This is the last one that people usually remember. They usually remember 90, 95, and 99. So 2.576. Fantastic. Okay. Okay, so we got 2.576 times P, P hat. So 42 divided by 97 is 0.4. 0.43 essentially. 0.57 over n equals 4%, 0.04. And again, you solve that for n, okay? And depending on the rounding, like this one, let me do this one for you. I'll get a little different answer than this because I rounded this to 43% and 57, but let me go ahead and do it just so you get the idea, okay? So the first thing I'm gonna do is I'm gonna go 0.04, you can see the equation, divided by 2.576. And you get that, okay? And then I'm gonna square it. And you get this little tiny number. Don't mess with it, so, okay? So I'm gonna end up multiplying n to both sides, and then you end up going 0.43 times 0.57 divided by second answer. And yeah, I get 1,016, okay? 1,017, which is a little bit less than this because I rounded that differently, but it's fine. Okay. Now, after all that, let's get to actually making a confidence interval, actually making one. Here's your procedure. Find p hat, no problem. Find the margin of error. And remember, the margin of error is z star times p hat 1 minus p hat over n. We're going to use p hat instead of p because we don't know what p is. And then your confidence interval will be that p hat plus the MOE, the margin of error. No problem at all. Okay. And I'm going to write these out every time. Okay. 18 of 52 people said they believe in ghosts. Create a 90% confidence interval for the percentage of people who do believe in ghosts. No problem, okay? So I'm gonna draw this out. So it's gonna be basically 18 out of 52 is about 35%. So I'm gonna draw this right here. So I'm gonna go 0.35 plus or minus 90% is 1.645 times, you ready? P, 0.35, 1 minus P, 0.65 over N, which is 52. And then you're gonna calculate that. Now, do not do this by hand. What I want you to do, now listen to me, is I want you to write it out like this, just like I wrote it out. Write it out. But stop there. After you write this out, I want you to go to your calculator and conduct this. Are you ready? I'm going to clear this. So write that down. I'm going to go to your calculator. Check this out. You're going to go stat. No. Let's see here. Stat tests. There we go. Stat tests. Stat tests. And we're going to do a 1 proportion z interval. 1 prop z interval. Check this out. Okay. You're going to put in the fraction. I believe the fraction was, what was it? 18 out of 52. Great. And 90%? No problem. This is so easy. Check this out. Whoops. Lost it. Okay. You're going to go 18 divided by 52. And you're going to do it to the 90th or 90. The confidence level is 90%. 90% is 0.9. Check this out. And you're done between 24% and 45%. It's easy, huh? You just got to write it out ahead of time. So there's your answer right there. Okay, let's do 3B. And again, I'll write it out a little bit differently on the notes here. 42 of 97 say, well, they will not vote in the election. Create a 95% confidence interval for the percentage of people who won't be voting. All right. So we have an estimate. Our estimate is about p hat. P hat is about 0.43. How did I get 0.43? I went 42 divided by 97. So we have an estimate of 43%, but we're probably off. So 95% confident is 1.96, if you recall that. And you're going to multiply times P, 43, 1 minus P, 57, over N, which is the denominator of 97. All you do is you write that out. You do not have to calculate it by hand. Just write that out. So please write that down. Then you're going to go to your calculator. See if I can squeeze both of them in at the same time. Kind of overlays. Okay. So you're going to go clear. You're going to go stat, arrow over to tests. And then you're going to find one prop Z interval, INT's interval. And that was, what were the numbers there? It was 42 over 97. So you're going to go 42 divided by 97. And it was a 95% confidence interval. Oops, what did I do wrong there? Okay, try that again. Stat, tests, one prop Z interval. Sorry about this. I think I did it right and clicked on it too quickly. Calculate. There we go. Got it. It's between 33% and 53%. It's a pretty big margin of error. I mean, it's 10% each way. Okay, because of the low sample size. 33 and 53. Okay, and that's of course what I have right here. If you see see this down here on these particular notes. Okay. All right, cool. All right, next problem. Okay, we got, like I said, we got 4 more of these. We'll get really good at them, okay? So let me make this a little smaller so I have this room up here to always operate. Okay, 3C. The Food Safety Committee randomly inspected 58 oranges and found that 7 of them were contaminated with fruit fly diseases. Can create a 99% confidence interval. No problem. Okay, so we got 7 over 58. Let me write. I'm going to write it up here. 7 over 58. That is a percentage of about 12%. Okay, so 0.12 plus or minus 99% is 2.576 standard deviations from the mean. Okay, and that's going to be 12%, 0.12, 0.88 over n, which is the denominator of 58. Okay, so you write this down. What I did right there. It's a little bit better than what I did in red here. This is going to be the answer between 1% and 23%. Okay, I did it in whole numbers for some reason. I probably shouldn't have done that. Okay, so get that written down. Now, let's go to the calculator and see what we got. All right. So we're going to clear this. Stat, arrow over to tests, and go to one prop Z interval. And I got to remember the numbers. I always forget. What we got? 7 out of 58 at 99%. 7 out of 58 at 99%, which is 0.99. Hit calculate. And it's between 1% and 23% is the truth. Again, pretty small sample size. So the point estimate was 12%, but we got like an 11% margin of error going each way. Okay. All right. Very cool. All right. Okay, the next one. D. A bag of N&Ns. Okay, it has 103 pieces of candy, 21 contain almonds, the rest peanuts. Create an 80% confidence interval for the percentage of N&Ns, candies that contain almonds. All right, no problem. First thing, p hat is 21 over 103, which is probably around, 20%. I have p hat at that. I'm going to put 20%. All right. So my estimate is 20%, plus or minus. I need to find what 80% confidence is, and I don't know that one. I'm going to go to this sheet. I'm going to look up 80% confident. There it is. 1.282 standard deviations. 1.282. So let me go back to this. And I'm going to write this down. 1.282 times 20% P, 1 minus P, or P hat, 1 minus P hat, over N, which is 103. All right, so get this written down right here, but don't do the calculations yourself. Let the calculator do that. You must put this to get credit. You got to show the setup, and then you can crunch the numbers via software. Okay? So let's go ahead and get the calculator out and try this again here. Here we go. Stat, arrow over to tests. 1 prop Z interval. And we got 21 over 103. And it's 80% confident, 0.8. There you go, between 15 and 25%. So it's a 5% margin of error. 20% was in the middle, 5% each way, 5% margin of error. Okay, about 15 to 25%, somewhere in there, okay? Which is what I got right here. All right, now let's do E and F. I'm gonna make this a little bigger. I'll have room at the bottom there. Here we go. So let's do E here. Okay, 11 of the 47 weightlifters interviewed admitted to using steroids. Oh boy. Create a 98% confidence interval for the percentage of weightlifters who have used steroids. All right, P hat's 23%. What we got here is 11 divided by 47. That's 23%. So 23% is our point estimate. We're going to be off a little bit, plus or minus. 98% confident. I don't memorize that one. So let me go to this, go to 98%, and it's 2.326. 2.326. You see it right here, 2.326. Okay? All right. So we're going to go 2.326. Okay. Erase this real quick. Okay. Times P, 0.23. 1 minus P, 0.77 over N, which is 47. It's probably going to be a pretty big margin of error because of the fact that I have a very small sample size. Once again, small samples vary more than large ones. I think it's amazing that the math actually does this logic for you. I think it's incredible. Okay, you see the answers between 9% and 38%. Okay, now your job is to write this down. Write down all of this. Then let the calculator crunch the numbers. Okay. All right, here we go. Erase this. I'm going to get to it. All right, we got 11 out of 47 at 98%. No problem. Okay, stats, tests, 1 prop Z interval. 11 out of 47 at 98%, 0.98 confidence. Oops, I did 95. 0.98. There we go. Wow, between 9% and 37%. I mean, the point estimate was 23%, right? So 23 plus 14 is 37, and minus 14 is 9%. 14% margin of error. Huge margin of error. You just can't sample that few people and really get anything that's worthwhile. You got to get around 1,000 to get anything worthwhile, which is what reputable companies do. Like Google will do that. So will Gallup poll. They'll do that, about 1,000. Just so you know. All right, last one. Okay, last one. 16 of 38. Here we go again. This is going to be a huge margin of error because that's such a small sample size. Admitted anonymously they have cheated. Oh, yeah. Create a 95% confidence interval for the percentage of students who have cheated on an exam. All right. 38 is not a big number. We're going to go with it. Okay, first of all, 38 is 16 out of 38 is around 42%. So here we go, 0.42 plus or minus. I've memorized 95%, 1.96 times P, 1 minus P over N, and N is 38, okay? Write that down, but you don't have to do the work. You know the answer is between, it's about, you can see it right here, 26% and 58%. A huge margin of error. So based on the survey that I did, I think I can conclude that between 26 and 58% of students cheat. That's a big gap. Okay, could be 1/4 or it could be over half. I just don't have enough data to really get that prediction any lower. But anyhow, let's do this on the calculator. Okay, so it's 16 of 38 at 95% confident. Okay, so stat tests, 1 prop z interval, 16 of 38 at 95% confident. Wow, pretty big margin of error, but there's the estimate. Okay, so go ahead and write that down. All right, so that is chapter 8, day 2, confidence intervals for proportions. Thanks for watching.